Hello everyone, welcome to the next issue of the Raku Challenges review. Today we are going to review the task number 81. While it's still Perl Weekly Challenge, it's completely incorrect. So the task is called Frequency Sort. You are given the file name input. Write a script to find the frequency of all the words. It should print the result, as first column of each line should be the frequency of the word, followed by all the words of that frequency arranged in by alphabet. Okay, so there's the text, and basically you are asked to ignore these characters. Remember this line, and we will see it a few minutes later. And the output is just the number of occurrences of that word, and then all those words sorted by alphabet. And also note that the capital letters come first, and the most common words are like and the. Okay, good. Let's go to the challenges, recap Raku solutions. Let me start with my solution. I have solved this task, basically straightforward. So there's the text, input txt.io.slurp. That's an incredible way of reading file in Raku. That's really simple, and here you are. You don't have to open a file, you don't have to read from it, you don't have to concatenate the strings, and you don't have to close the file. One line, even just a few characters, not just one line. Okay, then frequency. So you split the characters, the text by words. This is how I do that. W/W is the meta character for word characters, right? And I capture those, and I basically after this, in this loop, I've got the $_. I've got there all the words in the text. The only thing that this meta character also captures the underscore character. So you may want to maybe check this later, or like for example here in the loop, or maybe later, so you split the words or something like that, or you replace this underscore in the whole text before this loop. Basically it's up to you, but in this text there are no characters like underscore, and it was explicitly asked to replace all the like commas, dashes, and whatever was there. But I don't want to replace, I just want to read the exact information I want. So that's why this line. Okay, after that, so what I want to do, I want to get the frequency, basically the number of occurrences. It's not exactly the frequency. The strictly mathematical definition, or physical definition is a bit different, but nevertheless. So I took the values, and the values are basically the these one, the number of occurrences, right? Then why do I need unique and then sort? Because we want, like, in the first line to print 1, in the second line 2, and for each line we need all the words that we found these given number of times. Okay, the output collects the output, and basically those are the strings, one per number of occurrences. Here it is, and here I'm collecting the words. How do I do that? I'm grabbing the frequency hash where the value is the desired value at this loop iteration, and then I convert them to basically the key. What is the key? Basically the key will be so I will take this one. I grab that so that I take all the records for all the words where the number of occurrences is $freak, and after that I took the words themselves. So here I've got the words. So maybe this line looks a bit strange for example, a Perl developer, but nevertheless that's it's quite natural to write this line and to get the correct result. And after that I just sort the words, I concatenate them using the space, and I prepend the number of occurrences, and basically after that I just print this in the result. So simple. So Raku ch1 ch2, the input file is there. No such file. How can that be? cd-ash. Oh my god. So I have to do it like for every Raku ch2 Right, so yeah, I see. So these words appear 1 times, these words appear 9 times, and they are sorted alphabetically, and the first come words with capital letters. Right, so going next. Next solution by Arne Sommer, Raku 2. So here we have the file, and we want to, yeah, there's the default name as well, and here just directly in the signature of the main function we check if this file exists and if it's readable, and yeah, we have some default value. Yeah, maybe it's it looks like you want this construction like to put into single construction, but actually no, because this is a single construction, and this equals actually is about the default value for $file, not just you assign this to input txt. Okay, then again, frequency, file or slurp, the same as and then trans. So here we replace all the characters in this character range character class with spaces, then we substitute apostrophe s again with space, and do it globally. Oh, really? Subst. Wow, I didn't know that it's subst. Can subst. Where is it? Subst. Oh, yeah, so there are options like, yeah, global, this adverb. Wow, cool. Something new. And then we do the same with dashes, and then we split into words finally. Because all other characters are spaces now, and we make a bag. Yeah, bag is also an option, not necessarily it should be a hash. Right, then frequency and frequency keys sort map, and what we do, we sort. So we take the slice for this. We take the slice and we append the space, right? Append the words itself and the space after that, and we do that for all these. So yeah, I didn't quite understand that, but okay. And after that, you grab what is $_ here? So you grab the key, right? $_ is the key, and you, right, so basically here it's already the whole line, right? This is the number of repetitions, and this is the the list of words, and the list of words we format here, you see. So this tilde equals, it will just append. Okay. So right, so this one over which we scan, the key is the number of repetitions, right? Like 1, 2, 3, and so on, and 9 for the words and then and there, and this is the current string for that. And yeah, I find it a bit difficult to understand, but I kind of understood the idea, right? Arne is the default. Yeah, the result is definitely correct. Good. Yeah, well, yeah, the only exception is that, like you see, there are empty lines here as in the original task, but that's not at all important. Okay, Jan Krnavek. Right, so we've got the file as a string, IO of string. Wow, not quite clear for me. Then frequency sort and the named parameter input file, which is the file, and also there's the default method with --test. If you run it, it will call some functions, right, and make some checks. But frequency sort is the thing. So it takes the file. If it is there, it detoxes it, and you see, remember from the previous Raku reviews, this one is called method operation. So there's the function, but you can call it as a method on the object, basically on input. Input is a string. So this is what we call here, and the tox is basically, we translate this string so that we replace those characters with nothing, and then we substitute well, something with spaces globally and dashes. So yeah, detox. Okay, so removes just some toxical characters, well, basically non-word characters, right? And after that we can call word and then bag and then sort. Okay, and then classify. That's really cool. So we make some classification in the we classify the thing from the bag, right? The value, and we use it as key, right? Okay, so yeah, just read how you use these classify in the documentation, but nevertheless, yeah, it will just put all the words with the same bin, right? With the same number of repetitions, because the key is the word, and maybe yeah, for example, let's just run this one, Raku. So I have a string, hello world, hello there, right? Then I create a list of words, then I create a bag, and let's see there. So we see, so, and for example, if I will do that again, the keys are the words, and the values are the number of repetitions, right? So this is the word, this is number of repetition, and we make the classification for those. And frequency sort, that happens for that happens for the string, but here actually when we call this from the main function, probably it yeah, so this function is triggered, so we slurp the file first, we read all its text, and after that, same with is calling the same multi version of functions. See, so there's multi sub, actually, yeah, there's no sub keyword here, but yeah, it's necessary. I would put it there, but nevertheless, so same with, it just calls the function with the same name but with different arguments. So this time the argument is the string, right? Because after this slurping you've got the string, and this function, this multifunction is yeah, the will be run for that, right? Okay. Yeah, there's also this one. So if there's nothing, then you just try to read everything from input, I believe, right? Okay, so we are here at Arne, one bash Raku ch 2 yeah, so it waits for some input, and if we will do it like this, right, so it prints, yeah, well, this is a bit different, but nevertheless it looks completely correct, and it's also sorted by alphabet, right? Okay, the only thing I don't understand why we really need this and then why we don't just, why can't we just call .words, .bags, .bag, .sort, .classify, and so on. Okay, the next solution, Kang-min Liu, Raku number 2. So the main function takes the file, it's called input, I believe, right? Well, there's no file there. Print frequency table, word frequency of the path from this file, right? So we take the name, word frequency, and then print frequency table, right? So first we, yeah, add fric, quite an obvious name for the hash. What we do, we split the string by word border, right? By edges on the word, if I'm correct, right? And word, then it's a token, and if this token match, if this is letter, you see, so comma, sorry, the colon letter, the type, the Unicode, what is it? The Unicode class, right, of this character. And if this token, so token is this something, is not S and is not apostrophe, okay, then we, okay, so yeah, we kind of ignore, yeah, I wonder what happens actually in my solution where I just split word. So S will be, I believe, somewhere here, right? So this S probably is not exactly the correct thing. I wonder, by the way, what happens there. Perl weekly, it's still Perl. how can that be? So challenges, common base string, frequency sort. So where does S come in here? So it, first of all, see it doesn't, and also saw the words in the scanning order of frequency. So actually it's not quite clear whether we should, like this doesn't, is it one word? This is obviously one word. Well, there are two, but what happens if there's this like Bernardo Z? So yeah, should it appear? Well, according to this, it appears as Bernardo with no S. Okay, so yeah, maybe I didn't notice that. This is what I didn't mean. Okay, so yeah, for the sake of this task, please ignore the following input file. Okay, so I didn't read the task carefully. So okay, so you should explicitly ignore this, but you should not explicitly ignore this. Okay, right. So here we skip dollar apostrophe S, and the token is basically the word itself, and repeat it for all the words while we can do that. After that, we have this frec passed basically to print frequency table. You see, by the way, you passed the whole hash and just not a reference or whatever, as you would do in Perl. And yeah, you print your pairs, you scan the pairs of that hash, and this additional R frequency is where we append the additional word. And where do we saw? Here we saw that. And after that we saw the same frequencies by increasing number of repetitions, which is n, and print n, and all the words, and we saw it here. Okay, right. So here what we have to do, we have to Google Raku ch2, and like here, right, input like this. Okay, so we don't have S here, we have Bernardo here, and where is don't? Don't is doesn't, not don't, doesn't. Okay, you see, so apostrophe is lost, but it's not lost like, for example, here. It's also lost in my solution. So yeah, but okay, that's a minor thing. The next solution by Mark Anderson. Here's the solution. Let's just copy this to the text file so that we have some syntax highlighting. Right, so it's unit made some submain with the file. We freak sort this file and we join it with a couple of new lines. So we take the file, right, definitely with slurp, and then that's an interesting thing, because otherwise how you can append the next option, right, if you want it in one word. So you replace all the characters, and basically what's here, actually in Raku you can just do it like this. You can add some air. Why not, right? Like this, right? So there are three alternatives. One of them is apostrophe S. Probably you can even do it like this. Then like two dashes. Again, probably it's better to do it like that. And finally, well, not the final, but the first thing is the character class with parentheses, dot, comma, and double quote. Right, so I would definitely do it like this, because it's just a literal string, right? Why should we escape things? Okay, after that, gather, take. Wow, we just gather and take everything here. For this, syntax highlighting is still crap. And so we take this string, and immediately we've got this key, and key is obviously the number of repetitions, I believe. We so we replace those. After that, we do separate. We divide this into words, and that's our bag, and convert it to bag finally, right? So there are I think it's a bit inconsistent. You can either do that, or you can put bag here, but this is capital and this is lowercase. So yeah. And okay, you've got the bag, and after that, for all that bag, again, you classify that with the same conditions. The key goes there as the classification parameter, and so you sort this, and for all of them, you've got those basically pairs with the key and the value, and you sort the values because the value is obviously the words, right? Okay, right, so then we can go to Mark Anderson, Raku Ch2. Is there any input file? Right, okay, that's completely correct. There's no S here. There's apostrophe T in doesn't, and there's no S here. Okay, good. Markus Holzer. Right, so what we have here is unit submain with file, which is a file, right? So we ignore there's an explicit thing, and by the way, notice that's yeah, it's not an HTML comment, but yeah, this editor also gave some nice things. Right, so what we have here, so this is the array, and these quoting characters, basically they split everything in between by spaces, right, if I'm correct. So there are elements like this, like that. It looks maybe, yeah, quite unexpected, because usually you have words there, but yeah, why not? Okay, after that, so you've got the words, you take the file, yeah, this is where you don't need and then, you can just call methods, and actually, yeah, you see, so you don't have to use this unspace character, you can just continue on the next line and align all those dots. So IO, you create the object of IO path, right? Then you slurp the thing, and then you've got the text, you substitute all those things here. That's cute. I think we already saw somewhere some kind of construction where we have the array inside regex, and we replace this with a space, and we do it globally. Then we split it into words, we create the bag out of those words, and we classify the bag. You see that there's no as attribute here. After that, so yeah, we print for all those keys in the words. The only thing is that this dollar words. So yeah, what type is it? And yeah, so this is number of repetitions, and you sort this and convert all the things, and it take, well, it's not like convert, it's just taking the keys from all those words. Okay, so maybe I want to print these constructions somewhere. Right, so there's the file, I believe, somewhere here, but I want to run this from here. Raku, yeah, I need, so CP Pro Weekly Challenge Club Challenge 81 Ash, for example, Raku input, like here, Raku T and input, right? This is how I run it. Right, so this is the solution. Doesn't is there, S is not there, Bernardo is here. And what I want to do, it like to see what's there inside. Maybe it's a bit messy, the output will be a bit messy, but so you see that's the hash, any, and oh yeah, so there's another hash inside. Yeah, that's difficult to understand. So yeah, the key is the number of repetitions, and this is why we use it here, because sort keys, right? Yeah, I just wonder, like, what's the best, like this or for sort key? Yeah, both are okay. Okay, and this is the list of words together with their repetition. Yeah, okay, so that data structure is a bit redundant, obviously, because one is here and one is here, and the same for all other numbers. But nevertheless, yeah, the solution works. Cool. Yeah, this one is also fine. Even not fine, it's nice. Right, okay. Simon Proctor, rack number 2. So we've got the input file, right? We've got this map. Input file are words, so we immediately... Oh, really? Yeah, so you don't even slurp it. You just take these words directly from the file. And you map all the words. And you apply this point block with x as the parameter, which you can modify because it's a copy, and you replace all those things. Yeah, see, so here we have alternatives. Each alternative is quoted, and we replace them with nothing and return this one. Bag, anti-pairs. Anti-pairs is basically pairs, but where keys and values are swapped. And it's not end, right? So so this one starts here. This one ends here. This mapping stops here, right? So we mapped all the words. Well, basically for all the words, we replaced all these non-wanted characters, non-grata. Then we create bags and we take anti-pairs. Okay, so we're still here. So this is the $P is it's not pair, it's anti-pair. But its key is key push the value. Okay, so yeah, we append. If there's nothing there, we create an empty array, and if there is something there already, we will do append the word there, right? So, well, yeah, it's not a string yet, it's just an array inside this key. The key is number of repetition, and after that we solve this map, and we print the keys. This is the key, the number of repetition, and here this is the sorted joint list of words. Right, yeah, quite clear. Right. Right, Simon, Proctor, Raku, Ch2, input. Right. Cool, doesn't it there? Is there? Okay. Athanasius, Raku number 2. Right. Output. Yeah, the text is first edited to replace all those characters. Right. So we take where do we take the text from the input file? We slurp this, and by word text. So we Wait a minute, question mark here. What will it give us? I mean, yeah. Okay, it's not greedy, yeah, but how can it? Okay, then we take this word from the text. We still don't want the underscore. It's apostrophes, if any, are restored. Okay, so yeah, I see. So you first replace the apostrophe s with nothing, and apostrophe which is still left there with underscore. But first we remove this underscore, and after that we restore the apostrophe, basically for the word doesn't. This is required for that word, and we just increment ++ prefix form of the increment the number of repetitions for this given word. After that, by frequency, by word, keys and values. The key is the word, the value is the frequency, obviously, and we append the word to that array. See, so this is an array of strings. So yeah, and nice. So this is an array of string, and that's maybe, for me it was not quite clear when I first used this. So this is the hash, and this is the type of the elements in the hash. It's not the type of the hash, type of the elements in the hash. And you see, so in this case, actually you don't need to create, like in the previous solution, you don't need to create the / equals empty array. Remember that? So yeah, here we already have this. Yeah, we can just immediately start pushing to that array. Right, after that, so we loop over the keys, we map that to get it an integer, unsigned integer, we saw that. And this is frequency, and right, we then take the words by that frequency and sort the words. Right. Athanasius, Raku, Ch2, what is there? West Side Story. Right. Perfect. Perfectly correct solution. Colin Crain, Raku 2. Yeah, here it goes. Okay, so we've got already some text inside this, and notice this quoting thing. It goes until the end. The end is here, and also notice that this indentation before the end, well, yeah, without the underscore, it will be removed from all those lines, right? So it is really good thing in Raku. In Perl, you should really put it to the end of to the edge of the file, which is not, yeah, which basically breaks your indentation. Right. So you replace the characters again. Yeah. So this is what we saw already, but probably you can use. Well, I would use the quoted string here. Literal string, lowercase. Okay, so this is a bit different. So you edit lowercase and you remove the spaces, basically in the beginning and the end. After that, we split that by spaces. Basically, it's kind of the equivalent to calling words, right? Create the bag, and then directly in that bag, we take the keys and the values, and we append the word, which is the key here, to the hash at frequencies, keys, sort. So we sort this numerically. Probably it's a bit redundant, because what is the key here? It's the bag, so it should be okay. Yeah, but nevertheless, we don't have any more than 9 there. And format, so there's some formatting with some spaces, frequency, sort, join, right? So we see these should work. Okay, Raku, Colin Crain, Raku 2. There's some input there. So it's printed differently, but nevertheless, so yeah. So the first thing that is like not one line, but it's alphabetically sorted, and it's lowercase, right? So and doesn't is there, and Bernardo is here, and there's no S, right? Okay, good. Wait, why is it 11? 11, really? Is it something different? Is the text different? I mean, let's the like this, right? Yeah, it's 11. Okay, yeah, because the with capital T is 1, 2. Yeah, there are 2 capitalized. That's why it's 11. That's why we need this one. Okay, it goes beyond 9 actually. Okay, next solution is Jaldhar Vyas, Raku 2, and here we take the file, right? Oh, cool. The feed operator. It's not really a frequent friend, but it's quite useful. So we take that, read text, right? It returns something. We then pass those things. We feed it. We feed the next function with the output of the previous one. So we take the thing, we remove punctuation, then we again pass it to count words and then display. Okay, so read text. Read text, yeah, just slurp. Right, okay. After that, you've got the string, a single string. After that, remove punctuation. You've got the text. You remove all those characters. Yeah. So here it's finally, we see this one. Probably I would add a space here before the closing slash, because there's space here and the adverb is here. So you return processed, right? After that, we still have the string, and we've got the count words call. We pass the text, and yeah, after that we already will return the array. But here you don't see actually what type of data is passed here. So first we have the text, and we pass the text. Then we pass another text, and then we pass already an array. Okay, so the array, right. So we return the array from this function, but first we have to see how it's built. So we split the text by spaces and classify it by using the this thing, right? As a classification thing, it's maybe a bit strange thing. And count keys map. And then we map the keys to number of elements. So yeah, in this count is the classification. So here is how many elements we have, and it will be basically the, maybe I want to see the output of this file, right? Of this subroutine. So right, so here we have got this. I don't need this. I can save this, and I can go here, Raku T input usage. What do I mean? Yeah, okay. Raku. So okay, I will just do it like this. Right, Raku T. Okay, the result seems to be correct. So, but I wanted to see this basically like this, right? Right, so this is what we have here. So we have here the big sequence of pairs, right? Each pair is, the key is the number of repetitions, and the value is the word. Okay, so we take that, and then we create the frequency hash out of that by sorting the thing by its key, and the key is the number of repetitions and appending the thing, right? And but where do, okay, so we appended the frequency. Okay, we saw similar construction in one of the previous solutions when we created just a separate hash, and we pushed the values there, which we then later just join. Frequency, keys, sort, map, and print this word. Okay, cool, nice. Julio de Castro, Raku 2. Right, use V6D. Which version of Raku is it? So regular expression, regex actually. So it's by the way, see, so there's no assignment. There are bindings here, and there's regex. Don't backtrack this R, and if it's after L, and you see, so these are actually just quotes, these angle brackets which you cannot type from the keyboard. Right, so this is another way of quoting the thing. Why not? Yeah, just I don't know. Yeah, basically my way is just to copy these characters from somewhere from Google. But yeah, so after, so the L probably it's let, right? And then it's letter, but before letter potentially with an optional dashed. So potentially it's a sequence of letters dash another sequence of letter, and actually it can repeat more than once, right? So there potentially can be two dashes, right, in the word, and it should happen before the white space, preceded by S and followed by. So this is before, right? This is where before, and then after that, yeah, you can have letter. Okay, it may end. Maybe it's easier to read this. Don't backtrack. Don't match if preceded by word plus apostrophe. Avoids matching S in words. Match dash separated words. Yeah, we know that. It may end with apostrophe plus word except for S. Okay, so if it's not before, right, and it's not after. Okay, that's okay, and that's an optional thing. Which optional thing is it? Yeah, the whole thing is optional here. Okay, then so we've got this input file slurp, and immediately match against that regex. And the things which were matched, each of them, well, definitely it will be words, dash separated, and potentially like apostrophe T. And we convert all those to strings because this is the object of the match type. We don't want that. We want a string. That's the way to convert that. to a string. After the score, we take the score, we append, we take the thing and reduce it to, yeah, well, so this is the placeholder variable, and you see, so, wow, actually, oops, yeah, I probably never used it, actually, I only used to use the placeholder with the dollar, but obviously you can use the hash as the placeholder, which is cool. Right, and so you're using this rule, and basically you increment the number of repetitions and you return the whole hash there, right? And it's the score. Ooh, that's a difficult code. You take the data. What is data? That's the placeholder variable hash. Where does it come from, actually? Yeah. Ooh, I'm lost. So there's the score. Okay, so we've got the score. Then you add. You know what? I believe the best thing to run this, so we need the input file. Where is it? Input txt. So first we can run it like this one, right? And it prints the result. That's right. But after that, so let's dd words. So there are some words, that's an obvious thing, and among the words we see the doesn't is there, and Bernardo is here. You see, so without any S, and probably we will not see a single S there. I believe so, right? Because, yeah, it should be here, but it's not there. Right, okay, then dd score. Now we'll see, so there's like a big hash, the key is the word, the value is the number of repetitions, right? The number of repetitions, okay. Then this thing, oops, dd add. Here is the data, right? You see, so it's just a code block, right? And we use this code block here. We use this basically rule here. Probably we can just type it like this, right? Reduce using this thing, but yeah, it's kind of a function, anonymous code block saved in the add container, and after that you again reduce this, or it's the second call of reduce. Yeah, see, so you always need something here, the additional empty thing, and then flattened list of pairs here, right? Sequence of pairs, and you reduce it by pushing the key and returning this one. Okay, yeah, I'm a bit lost here, but definitely it works. Definitely it works, and it's a nice solution. Well, yeah, everything is difficult here. I mean, the regular expression, it's smart, and this is also smart, and it works, which is good. Okay. Raku number 2 by Laurent Rosenfeld. Here it is. Let's have some syntax highlighting. Well, not that helpful because of that, I believe. This quote. So we've got the text, West Side Story txt. We slope that, and you see, so it's just even better way, probably, instead of just, yeah, actually it's less typing, right? Right, so you've sloped this file, you've got this string. Yeah, you gain some characters here, but you add the type here, so you add some characters, right? But that's a cool way to use in Golf, right? Then you remove the things, you remove this or this. You see, there's 2 vertical bars, by the way, and after that you create a bag. Well, here you will not gain any characters. If you will use a postfix notation, the method call bag histogram of words, and finally the summary. The summary, you append every key from the bag, basically the word, and no, it's not the word, right? Wait. DD. Let's look at this one, right? Input. No, it's West Side Story, but it's input in our case. Right, this one. So this is, yeah, so this is the word. The word is the key, so it's opposite to what we had here. So the key is the word. This is, yeah, I was correct. And then you sort this. Where do we count? We count here, right? Because here, after this back, the words like this one are already counted. And is 9. And the is also 9. Right. And summary sort, so you join the words, and this is number of repetitions, and here it is. Okay, it doesn't belongs here. Okay, right, good. Mohammad S Anwar, number 2. So here's the solution. What we do, we take the file and pass it to the fetch words and then frequency count functions. Fetch words, take the file. Yeah, so there's another option. Just read the lines and replace the things in all the lines, and after that you split the words in all the lines actually, right? So you repeat this for loop for every line in the file, and I don't understand why this dot is here. Why is it needed here? +1 or just plus I would say, and return the words, and the words is actually, it's a hash ref, right? So this is a hash, the containing a hash. And yeah, okay, so the same story, you fill the frequency hash with the words, and then you sort this, right, numerically, and the count, you print this frequency sort join. Yeah, this is how I did. So this is a list, contains this list contains the number of repetitions and all the words sorted already, and after that you join that. Basically you join this one together with the words, right? Raku, Mohammed, Raku 2. Do we need something? I forgot. There's no text, really. There's no text. File. Alright, does not. No S. Bernardo repeats twice. That's correct, right? Yeah, but by the way, in my solution, I believe Bernardo repeats. No, Bernardo is also, yeah, it should be twice because this S I count as a separate word. Okay, good. Going next. The next solution is by Myoungjin Jeon, Raku 2. Here it is, right? So there are some comments which credit Mark Anderson. Thank you, Mark Anderson. So yeah, there's the unfolded version, which is probably the thing we'd like to do, but actually this one is not that difficult, right? So let's look at this one. So begin. Yeah, so that's a new pod. So we take the word. So we take the file, and we check if it's readable. Otherwise, yeah, we can continue. Yeah, that's an option. With so we typicalize the IO path object here, right? After that, my R. Okay, so here's the continuation. So yeah, it's a separate line, but actually there's no comma here, so semicolon here, so it's actually the postfix for loop. And for this bag, what we do, we push the keys, and we after that we sort that, like we sort on every iteration, if I'm correct, right? So the bag is just the dot words. The dot is called on this object, the IO path, right? And all those words. Oh, that's very, very, very like lots of nested, not nasty, but not nested things happen here, and right, we substitute that with nothing, right? So we replace all those characters. And you see, so there's a difference, right? If I'm correct, that's the character class of all non-letters without the dash, right? So without this character class, without this character class, right? So this character class contains of all non-letter characters, including dash, right? Obviously, and it's minus, and this, well, minus represented by a dash ASCII characters, right? And this is really like a dash. Character class of a single character, right? Or double dash and replace that with nothing globally, and after that we append it here. The only thing, I think it looks like indeed we sort it every time, right? We sort it more than once. After that we sort it's actually an interesting thing that I can sort hash and we join it and we print it. Right, what I want to do, I want to our usage, right? So I want just to copy this everything to a text editor and run it from here. So I want like input txt, right? Raku t. So the result is correct. Bernardo twice. Where is does not without the apostrophe? That's not completely correct, but yeah, my solution was even more incorrect. But nonetheless, so what I want to print this one, dr. I just want to see what's there inside. So you see it's there inside. So there's an array here and a list here, right, of one character. And after that, when you sort that, what do you have here? You basically get that sorted by this one, right? The sequence, right? Okay, but this is probably this one is one of the most interesting additions to Raku, where you can just sort the hash, and additionally, definitely you can have some conditions. We saw that already in other solutions. Okay, Roger Bell West, so Raku number 2. Raku number 2, and so yeah, what we do, so we just immediately call lines, which basically reads from the command line, and we chop that, remove, the new lines, we copy this current thing into the variable s, because we are going to replace the characters we don't want there, and then immediately map in the map. So what we do, map over grep. So we take all those. No, wait. First we split this by space, but probably we should split by s plus, right? So that all the spaces are a single separator. And then we take something with at least a character in it, and then we just fill the frequency hash. And after that, we sort this frequency hash by keys. The keys are the words, right? And we append this. So again, this schema with 2 hashes. And then we sort the frequencies and join it. Again, we join the frequency and the words. The words are already there, and we join them. And yeah, that's it. Okay, right. CD Roger Will West Raku ch 2. Is there any file? No, so we have to pass this input. Yes. Okay, Bernardo twice coexist and does not in OS. No, yeah, correct solution. Well, yeah, maybe with the only exception that this line is probably redundant, but that's, this is because of this one, and that's a bit painful just to program correctly. Okay, and it was the last solution in this list. And that was this 55 minutes of the Raku challenges of the week number 81 and the task number 2, where we sorted the frequency of the words. And that's it. So yeah, see you next time. Thank you very much. Goodbye.